Hello students, welcome to the new semester and welcome to this subject on industrial metallurgy UME 733. I hope you are doing good at your respective places and I wish that you remain safe and healthy. My name is Tarun Nanda and I'm working as an associate professor in mechanical engineering department and I'll be taking up this course with you along with two of my colleagues, Dr. Satish Kumar and Dr. Dinesh Rathod. The first module or the first session will talk about metallurgy and its scope. These are the contents that we'll cover in this online session. See, metallurgy is defined as the field under science and technology and now under engineering, which deals with the procurement of the metals from their ores and then adapting them to satisfy human wants. Metallurgy is, in simple words, the science and technology of metals. So if you look at this definition, you will see that there are two distinct parts. In the first part, we say that we have to procure the metal from its ores because generally metals are not present in their native state, in their pure state. So the first step is to mine them out from their ores and bring them into their purest form. But even when they have been brought to their purest form, they are not still industry ready. So they have to be transformed, they have to be changed, their properties have to be improved upon. That is what is meant by adapting them to satisfy human needs or engineering applications. So this is the second part of metallurgy. So as the next bullet point tells you, metallurgy has got two main branches: extractive metallurgy, which is also called chemical metallurgy or process metallurgy. This is that first part dealing with the procurement of the metals from their ores. And the second part is called physical metallurgy or popularly called industrial metallurgy, where we bring about changes in the properties of the pure metal so that they are able to satisfy the engineering applications. So what is extractive metallurgy? As we discussed, you see there are plenty of metals which are present in the Earth's crust, which are present on the Earth's surface, but majority of these metals are not present in their usable form. They are combined with other non-metallic impurities like in substances similar to clay, dust, not exactly dust, but clay, stones, rocks, etc. So metals are not present in their native state, rather are present in their combined state. So the first thing that we have to do in order to make these metals useful for human application is that we have to liberate them from their combined state and we have to bring them in their native or pure state. And this is where extractive metallurgy comes to our rescue. These are the 6 main steps that are used in extractive metallurgy: mining, crushing, pulverization, concentration, extraction, and refining. See, in mining, we locate where is the ore of the metal. We dig out this ore. So metal of the ore is obtained in the form of big rocks, big lumps. And these are the machines that are used for the purpose. Then we move to the second step of extractive metallurgy, also called process metallurgy or chemical metallurgy. And here, these big lumps of rocks that we had mined out, they are broken down into smaller pieces. Machines used are called jaw crushers, etc. Then we move to the second step, third step called pulverization. The crushed ore from the second step is now grounded into the form of a fine powder using machines called stamp mills or ball mills. Then we take this pulverized ore, finely powdered ore, to the fourth step, which is called concentration. This is also known as ore dressing or beneficiation process. Here in this step, from this finely powdered pulverized ore, we remove all the physical impurities, all the impurities that were not attached to the ore chemically. So all non-chemical impurities are now removed from the ore. These impurities are generally called matrix or gangue. We take this concentrated ore to the next step, which is the real step called extraction. It is because of this step that this part of metallurgy, this branch of metallurgy, gets the name extractive metallurgy. Here, the concentrated ore is converted with the help of some processes into what is called the free metal or the crude metal. In the first, there are two main steps. In the first step, this concentrated ore is converted into a suitable metal oxide using processes like calcination and roasting. And in the second step, the metal oxide is reduced with the help of processes like smelting, etc., and we obtain what is called the free metal or the crude metal. But this metal is still not the pure metal, because there are certain impurities, though in traces, which are still attached to the metal and which got attached during this reduction process. So we still need another step, the final step called refining. And in refining, we basically change the crude metal or the free metal that we had obtained because of this step, and this crude metal or free metal, with the help of certain refining processes, is converted into what is called pure metal. The processes that we generally use are listed on this slide, and these are the sources why certain chemical impurities are still present even after the extraction process. So next slide would show you some of the equipment that is generally used for extractive metallurgy. Here in this slide, I am showing the various equipment that are used for mining. Then here we are showing some of the equipment that are used for crushing, for extraction, etc., refining, etc., etc. Then the problem is that even after having done so much to obtain this pure metal, we followed 6 different vast steps to obtain the pure metal. But still, the pure metal that you get, and most of the pure metals that you get, are only good in some physical properties, like they will have very good corrosion resistance, they will offer you very good luster, they will give you, say, very good means some physical properties would be given. But when it comes to real engineering properties, those are mechanical properties. And mechanical properties include properties like hardness, properties like strength, properties like toughness, etc., etc. Most of the metals have got very poor values for these properties. So the pure metals that you have obtained after extractive metallurgy are generally not fit for engineering applications, and it is here that physical metallurgy or industrial metallurgy comes to your rescue, which brings about transformations within the metals system so as to get improved properties in them. And students, here I am showing the 3 main routes, the 3 main processes, or what we say the 3 main control variables through which physical metallurgy brings about changes in the properties of a metal system. So in physical metallurgy, we study that why a particular material is showing a particular set of mechanical properties, and we also study as to how those mechanical properties being possessed by a material can be enhanced, can be changed, and what are the 3 main control variables that we have through which mechanical properties can be changed. One is alloying. You know, pure iron has got very poor mechanical properties, but when you add a bit of carbon into it and you make steel out of pure iron. For example, if you add 0.1% carbon into iron, it becomes an iron carbon alloy and is popularly called steel. That steel would have dramatically improved properties as compared to pure iron. So if you add up to 2.11% by weight carbon, iron carbon alloys are called steel. If you add carbon beyond that, iron carbon alloys are called cast irons, and both of them have drastically, significantly improved properties over pure iron. So what you have done, alloying. So in physical metallurgy, we'll study why, because of alloying, properties of a metal system change and how they can be changed, what type of alloying can bring about what type of change. That complete understanding is gained through in physical metallurgy. Similarly, mechanical treatment means any treatment given to a material system because of which its shape is changed or size is changed, or both shape and size are changed. For example, in manufacturing processes, you studied rolling, forging, extrusion. All these are mechanical treatments. So in physical metallurgy, we study that when a particular mechanical treatment is given to a metals system, why do its properties changed? How can its properties be changed to advantage, etc., etc. And third control variable under physical metallurgy is called heat treatment, where we do none of these two things. We do not change the chemical composition. We do not give any mechanical treatment in any heat treatment process. Annealing, normalizing are the different processes that we use. We have to do simple heating of the metal or an alloy, some soaking at that temperature, simple cooling. And just because of these three single steps, the properties of a metal or an alloy system will drastically get improved. So students, with the help of these three control variables, physical metallurgy tells us how you can have total control over the mechanical properties of a metals system. So that also shows that what's the scope of this subject. So in this subject, you will try to learn why does a particular metal or an alloy system behave in the manner in which it is behaving? Why is it showing a particular set of mechanical properties to you? And then if you are not happy with those mechanical properties, this subject would also explain as to what processes or treatments can be given to that metal or an alloy system so that you get the desirable mechanical properties into your metals or an alloy system. And this brings us to the end of session 1. Thanks for your patience. Thanks for watching. Thank you so much. Thank you.